Hi, it's time for another math easy solution. To discuss further into conic sections, look further into ellipses, and now go over some very interesting applications of ellipses, and that's in lithotripsy as well as whispering galleries, as well as I'll show some really cool elliptical artwork in this video. So that's going to be pretty interesting. Let's just jump right in. So recall the interesting property of ellipses from my earlier video, so make sure to watch that. That's in the link in the description below. So yeah, from that video I showed that like parabolas, ellipses have an interesting reflection property that has practical consequences. If a source of light or sound is placed at one focus of a surface with elliptical cross sections, then all the light or sound is reflected off the surface to the other focus, or one focus off that elliptical cross section or reflector right back to the other focus. This principle is used in lithotripsy, a treatment for kidney stones. I'll go over this in more detail in a bit. A reflector with elliptical cross section is placed in such a way that the kidney stone is at one focus. High intensity sound waves generated at the other focus are reflected to the stone and destroy it without damaging surrounding tissue. The patient is spared the trauma of surgery and recovers within a few days. Again, I'll get to that in a bit. But first, to understand how this works, let's first take a look at the law of reflection. Here's from University of Texas website, law of reflection. The law of reflection governs the reflection of light rays off smooth conducting surfaces such as polished metal or metal-coated glass mirrors. So basically, consider a light ray incident on a plane mirror as shown here. The law of reflection states that the incident ray, the reflected ray, so here's the light ray here and the reflected one here, and the normal to the normal of the surface, or the normal to the surface of the mirror, here's the normal or just a perpendicular line to this mirror, all lie on the same plane. So yeah, and just look at it in 2D, so this is all on that same horizontal plane. Yeah, furthermore, the angle of reflection is equal to the angle of incidence I, so we have R equals to I equals to R, and this is the major one I want you to get into your head. So yeah, both angles are measured with respect to the normal of the mirror, so they're doing angle from there, but this is 90 degrees both sides, so you could even see, well, this is going to be the same. These are both going to be the exact same. We'll call that theta. Yeah, so now let's just consider, let's say we had a mirror or reflector here, mirror or some other sort of reflector, and let's say you have a light or sound. Let's say if you go perfectly horizontal, this is light or even sound or whatnot. What happens is this bounces off in a perfectly 90 degrees. So this is, you're throwing it off at a 90 degree angle, it's going to reflect back 90 degrees. But now if we tilt that mirror something like this, so what we end up having is, this is your light going across this one, now this will reflect, if this is, first of all you could do is look at the normal. So there's the normal or the 90 degrees one. This angle, we'll call this, actually that's gamma, so that's gamma, Greek symbol. So then this one's going to get reflected off. We have to draw this like that. This is also going to be gamma, and it's going to look something like that, and that is where the light source gets reflected again. As I showed above, it's the same thing. So you can have this angle, this angle like that, theta. And this, again, I drew it like that just because it looks very similar to the video I did in my last video. So recall from my last video that if we had an elliptical reflector, that if the reflector was an ellipse, so let's say you had a surface like this, and this is an ellipse, like that. Yeah, here I just drew this a bit better. So let's say you had an elliptical reflector, fix that spelling up, elliptical reflector or mirror or whatnot. And then let's say you had, this is the focus, one of these focus right here. The second one is here. Remember I showed that if you had let's say a line across there, or any sort of sound or light, this gets reflected right across here. And as I showed, if you draw the tangent line to this, just drew that better like that. So this is a tangent line across to it. So if you're going across like that, it will reflect back here. And as I showed, this angle, I'll call that theta, is exactly this angle, theta. And hence this could be like a mirror reflector. Exactly the same principle applies by the law of reflection. Yeah, so thus that's how it works. You have one focus. If you have a light or sound coming from this focus, bounce it off anywhere, will it reach here? Even if you bounce it off, let's say here, it's just gonna still go all the way to there. Because now you have this line across here, tangent line is gonna be same angles across, exact same, reflecting it off. Yeah, and here I quickly just change that color to red so it looks a bit better. As you see, it reflects there and bounces off there. So it doesn't matter where it is on that. On that reflected reflector elliptical shape right there. Even if you go to the left right here, go right here, it's going to go bounce right back. Yeah, so let's look at now applications of ellipse in more detail. So lithotripsy right here. This is from the Wikipedia page. So lithotripsy is a medical procedure involving the physical destruction of hardened masses like kidney stones, bezoars, or gallstones. The term is derived from the Greek words meaning breaking or pulverizing stones. Now if you go to medicinenet.com, has a good illustration of kidney stones right here. So kidney stones, facts: a kidney stone is a hard crystalline mineral material formed within the kidney or urinary tract. Nephrolysis or whatever is the medical term for kidney stones. 1 in every 20 people develop kidney stones at some point in their life. Kidney stones from when there is a decrease, they form when there's a decrease in urine volume and or excess of stone forming substances in the urine. Dehydration is a major risk factor for kidney stone formation. Symptoms of a kidney stone include flank pain. The pain can be quite severe and blood in the urine, hematuria, whatever. So there is your 2 kidneys right there, and there is an illustration of a kidney stone, just a dry, hard, mineral crystalline material. Again, formed likely because of dehydration. So yeah, make sure to drink lots of water. So anyways, now if you go to Math Central, this is on University of Regina website, lithotripsy, a medical application of the ellipse, extracorporeal shockwave lithotripsy. So this ESWL type of lithotripsy enables doctors to treat kidney and gallstones without open surgery. By using this alternative, risks associated with surgery are significantly reduced. There's a smaller possibility of infections and less recovery time is required than first surgical procedure. The Lithotripter is the instrument used in lithotripsy. The mathematical properties of an ellipse provide the basis for this medical invention. The foci, going further, the Lithotripter machine has a half ellipsoid shaped piece that rests opening to the patient's side. An ellipsoid is a 3-dimensional representation of an ellipse, is a 3D ellipse. In order for the lithotripter to work using the reflective property of the ellipse, the patient's stone must be at one focus point of the ellipsoid. So you set that at one focus point, and then the shockwave generator at the other focus. So here's that shockwave, sends sound across and then goes and basically kills that kidney stone or destroys it. The patient is laid on the table, moved into a position next to the lithotripter. Doctors use a fluoroscopic X-ray system to maintain a visual of the stone. It's like a video game. This allows for accurate positioning of the stone as a focus. Because the stone is acting as one of the focus points, it is imperative that the stone be at precisely the right distance from the focus located on the lithotripter. And this is essential in order for the shockwaves to be directed on the stone. And so they use X-rays to try to find out where the stone is, and then they keep moving the device around until it's focused right on it, and then you can start firing at it. Now going further, here's from another website. I found this random website, not sure where this is from. But as a good illustration of medical lithotripsy right here. So kidney stone is by Mark France. Kidney stone at focal point here, and then you have that device across here sending those shock waves. And I believe there's a water cushion because might have it easier to travel those sound waves and whatnot. And there's the ellipsoidal reflector, just a 3D ellipse shape around, everything bouncing off goes to that point, which is quite fascinating. Then here's another website from medpagetoday.com, and this is wondering if people should retire the lithotripsy for kidney stone. Proponents and opponents had their say during the AUA meeting, so I guess there's some debate going on about that. But here is one of the lithotripsy devices. See, there's that water cushion. I believe there's something there you can see with the x-ray where the stone is, and there it is, how it looks like, one type of it. And yeah, just sending shock waves with an ellipsoid shape inside. So and now another application of ellipses is whispering gallery. So whispering gallery is usually a circular, hemispherical, or even elliptical or ellipsoidal enclosure, often beneath a dome or a vault. Yeah, in which whispers can be heard clearly in other parts of the gallery. That's very cool. Such galleries can be set up using two parabolic dishes. Sometimes the phenomenon is detected in caves, and yeah, that's how you could hear those echoes in caves and stuff. So theory, the gallery may also be in the form of an ellipse or ellipsoid. I just wanted to focus on this one, with an accessible point at each focus. In this case, when a visitor stands at one focus and whispers, the line of sound emanating from this focus reflects directly to the focus at the other end of the gallery where the whispers may be heard. Yeah, it's pretty cool. So here's another website, cnx.org. It has a pretty good illustration of this ellipsoid. Yeah, shapes, solving applied problems with involving ellipses. Many real-world situations can be represented by ellipse, including orbits of planets, satellites, moons, and comets, and the shapes of boat keels. I'm not 100% sure what that is. Rudders and some airplane wings. A medical device called a lithotripter uses elliptical reflectors to break up kidney stones by generating sound waves. Some buildings called whispering chambers or whispering galleries are designed with elliptical domes so that a person whispering at one focus can be easily heard by someone standing at the other focus. This occurs because of the acoustic properties in an ellipse. When a sound wave originates at one focus of whispering chamber, the sound will be reflected off the elliptical dome and back to the other focus. And here's the figure right here. It's a pretty cool illustration. I just wanted to show that this website because it has this cool figure there. So you can imagine just an elliptical dome, and then you talk here, you can hear over there. If someone's say at a restaurant like this, so if you have dinner at this table, you can overhear what this person is talking about. I think that'll be very bizarre but very cool. And yeah, in the whisper chamber at the Museum of Science and Industry in Chicago, two people stand at the foci about 43 feet apart. Can hear each other whisper. That's pretty far. So, and here's sound waves. Oops, why is there a dot? Yeah, so figure 8 sound waves are reflected between foci in an elliptical room called a whispering chamber. And here is that Museum of Science and Industry in Chicago website right here, Museum of Science and Industry, or msi.chicago.org. So this is part of their museum, Make Yourself Heard. So the acoustic design of the Whispering Gallery lets you talk in the quietest of voices to someone across the room and be heard perfectly. And here's how it looks like. A museum favorite since 1938, the acoustic Whispering Gallery still sounds as good as it looks. You and a friend stand with your backs to each other at either end of this long room. When you whisper in the curved dish in front of you, your friend across the room hears you as though you are inches away. No wires, no power. Can you figure out how it works? As I just showed above. So this is a very cool. So you can just talk here. You can step on this thing right here and talk. Then that's the focus that's set up here or wherever you're standing. Then you talk here, bounces, and then goes all the way across. Yeah, I guess everywhere actually. This bounces. If you talk here, it bounces here, goes all the way back. But then if the sound coming, because it doesn't just go directly straight, wherever it goes is gonna bounce off all the way to this person there. This person. This sound goes all the way across there, and there's another one standing. It's just quite quite fascinating. I gotta go there and check it out. So yeah, if you're in Chicago, go there and let me know how it sounds. Another cool figure, this is from daviddarling.info, just a random one I found. So here you could talk, it looks like you could talk to different people across it. So Paris metro tunnels are almost elliptical, and whispering on one platform can be heard on the other by the focusing effect, which is pretty cool. So yeah, so if there's an emergency or just employees want to talk to each other, workers there, it's a really cool method to just talk directly across without using a phone or anything. It's quite amazing. And yeah, now we'll go to this other website, Pleacher.com. Has some pretty cool ellipses or applications of ellipses, which are pretty cool here. So whispering galleries in the old House of Representatives in the U.S. Statuary Hall in the U.S. Capitol building is elliptical. Yeah, so that's Statuary Hall. It was in this room that John Quincy Adams, while a member of the House of Representatives, discovered this acoustical phenomenon. That's interesting if true. Yeah, this is just a random website. I just wanted to show us some pretty cool info. But I haven't verified all the facts in it. So yeah, let me know if anything is wrong. So yeah, he basically is saying John Quincy Adams, he situated his desk at a focal point of the elliptical ceiling, easily eavesdropping on the private conversations of other House members located near the other focal point. That's pretty cool. So now I'll go further. Whispering galleries. I believe even the Mormon Tabernacle, the Tabernacle building in Salt Lake City has an elliptical ceiling. You can hear a pin drop from 175 feet. The Tabernacle is 250 feet long, 150 feet wide, and 80 feet wide. The organ has 11,623 pipes. So that's pretty cool. That's the outer one. There's an elliptical shape on the around. Now if you're inside here, so that's I believe one focus, and this can go really far away. It's quite fascinating. And here is the old photo of it. Yeah, it looks like just I don't know what that shape is. But yes, nonetheless, let's go on further. Another cool thing. So there's an elliptical pool table. The reflection property of the ellipse is useful in an elliptical pool. If you hit the ball so that it goes through one focus, it will reflect off the ellipse and go into the hole which is located at the other focus. Yeah, that's actually a very cool idea. I didn't realize until just now. So for what this is saying is that if you have an elliptical shape, like let's say you're playing pool, there's a hole there. That's, remember, this is at one focus. So what you do, let's say your ball is right over here. Let's say you have, this is the ball, and well, actually I'll change the colors. Let's say the ball is just like that. This is the one, we'll draw this inside. That's the hole, and this is, I'll call it F1 for the focus. Yeah, the first focus. So instead of trying to aim from here to, let's say, trying to shoot it from there to there, because that's pretty far, what you can do is, well, go at where the second focus is, which should be somewhere over here. This would be somewhere over here. This is F2, and because this is a focus right here, and this is closer, so all you gotta do is aim here. So if you aim here, this will go through the focus, and then it will bounce wherever it's gonna bounce, and then it's gonna go there. So you that's pretty cool. So this is better, I think. This is, well, shorter or easier. Put in a quotation mark because I'm not 100% sure. I haven't played elliptical pool, but this is practical. That's pretty cool. Instead of just aiming at it in the long way, you should do that. So yeah, pretty cool stuff. If you have an elliptical pool table, let me know how it works. I wanna get one too. So yeah, that's a cool application of ellipses like there. That's quite fascinating. So, and also there's an ellipse in DC, Washington DC. The ellipse near the White House in Washington DC is aptly named the Ellipse. So yeah, that's a ellipse over there. And also, yeah, it looks like I gotta get myself an elliptical pool table. #I want. Yeah, and also going further, yeah, I also found some amazing ellipse artwork and just overall architecture work. I tweeted this out earlier. This amazing architectures from architects.org, and I'll show you the images, how it looks like. So here's one of them right here. So this just looks like, you know, just random shapes over there everywhere, painted on the walls. But if you go to a correct angle, you can see it looks like it's augmented reality, or someone photoshopped real life right here. So I thought these were Photoshop. Look at that. So someone's actually standing here, but this is actually the same building over there. It's depending on the angle. Now here's another example. If you go to this angle, this looks like it's literally standing out in the in 3D space, but as you can see, these are all just painted across in just such a way that at one angle it will look really cool. So yeah, I just wanted to show that because I found this oval there. So yeah, this looks like just a giant oval someone drew on this photo, but in fact it's painted on the pillar in the wall in such a way that only from this view you could see that ellipse. So I initially thought the photos were Photoshop, but then I realized that real life was Photoshop. Hashtag architecture meets augmented reality. So yeah, let me know of any other cool ellipse applications or artwork. There's some pretty cool stuff. Anyways, that's all for today. If you learned from this just a random sidetrack from my usual solutions videos, just wanted to go over some applications of ellipses, some pretty cool stuff. And yeah, I want to try out the that pool right here. That'll be pretty cool, especially playing against beginners, if you get good at shooting at the other focus, which is quite fascinating. And yeah, some other healthcare stuff, all because of ellipses. So pretty cool. And yeah, that's all for today. If you learn, like always, you can download these exact notes in a link in the description below, as well as viewing these in article format on Steemit. So you follow me there at MES. Anyways, thanks for watching, and stay tuned for another Math Easy Solution.